So today we're going to work on finding vertical asymptotes and holes. In this problem specifically, we're just looking for vertical asymptotes. So we're kind of separating everything for a little while, and then we'll put everything together at the end on every problem. We're going to do everything. So for now, what I'm going to give us is my three-step process. Wink, wink. Step 0 is there, but we're going to call it step 0 because it's actually how we do step 1. So three-step process to find vertical asymptotes. And we're also in the process, we're going to point out the holes. We're just going to only be focusing on answering the question with vertical asymptotes here. So to do these problems, our job is to identify points of discontinuity and then classify them down here between holes or vertical asymptotes. So we're going to see what it causes each to happen. Now, the process has to go through factoring the denominator because we could, without factoring, identify the point of discontinuity by saying, what causes 6x minus 15 to be equal to 0? And then solving that, and you get x equals 15 over 6, and then you would reduce that to be 5 over 2. The problem is that is the point of discontinuity. It just doesn't allow me to do the rest of the process to know whether or not this is a hole or a vertical asymptote. All we would know is like, yeah, that's a point of discontinuity. Well, the best way to do this process and have a systematic way of working it is to factor the denominator. So recognizing these have a 3 in common, I can factor out the 3 and make this 3 times 2x minus 5. So that's the denominator just factored. And now identify my point of discontinuity. Well, that just means to do the work I just did with this factored form, set it equal to 0 and solve. Well, the only part that matters is that inside, and we get 2x minus 5 equal to 0, which will produce x equals 5 halves as a problem called a point of discontinuity. So right now I could say my domain for this function is all real numbers, comma, x doesn't equal 5 halves. So that we're identifying there is a point of discontinuity amongst the infinite domain. There's one point that doesn't work. Anyway, the point is now we have to work this process of factoring the numerator and seeing if anything cancels. Well, this particular numerator is linear with no common factors, so it's done. It's checked that off. It's really if possible. Factor the numerator if you can. So here we have x plus 8. Now our job is to work step 3. Step 3 is a sort step, where you're just sorting after reducing the function if possible. Well, this particular function, as it stands, is fully reduced. There's nothing to vertically cancel. And don't get excited that there's an x on top and bottom. You cannot cancel those. It has to be a whole binomial or a whole GCF out in front that can be canceled. Nothing can be canceled here. And so this is reduced. So check that part off. But now what that means is we're supposed to work these two options. So coming down here, factors that reduce out produce holes. Well, nothing reduced out, so I don't have any of those. And so I go to the next place where the remaining factors produce vertical asymptotes. Well, this remaining factor is this 2x minus 5 that I'm talking about. And so what that means is it produced this point of discontinuity of 5 halves. Since it remains in the fully factored form, we now name that a vertical asymptote. So this problem, all that to say, has a vertical asymptote of VA, period for short, at x equals 5 halves. Now we need to write the x equals 5 halves because it's a vertical line. So what's happening is at the x value of 5 halves, you would have, so which is like 2.5 here, we would put a dotted line to identify that there is a vertical asymptote where this graph heads to either positive or negative infinity on each side of this line. And that's a conversation for another day when we get into graphing. But for now, 5 halves is the vertical asymptote.